choose the graph of the inequality. And here we have a system of inequalities. We have y is greater than or equal to x squared minus 1. And then we have x squared plus y squared is less than 9. So before we jump into trying to decide which one of these is the correct graph, let's look at these individual functions separately. So the first one, where I have y is greater than or equal to x squared minus 1. So this is going to be a parabola, and that vertex of this parabola is easily seen here. And that vertex is at 0 on the x, because there's no change to the x here, then -1 on the y. Okay, now let's see what else we can determine about this. Now, there's a greater than or equal to, and whenever you have greater than or equal to or less than or equal to, that represents inclusion. So you're including the boundary. And so what you do in your graph is you make a solid line, or a solid curve if you want to call it that. If it were a less than or greater than, then that would be exclusion. And there you graph using a dashed line. Okay, so we're going to use a solid line when we graph this. And it's a parabola opening upward. Now, we might be able to rule some things out just from these pieces right here. So in part A, we certainly have a parabola that is opening upward and has a vertex here at, well, no, that's not at the right spot. That's at 0, 1, not 0, -1. So that we can rule out. This one has the parabola's vertex at 0, 2, so that can be ruled out. This is the only one with the parabola the vertex is at 0, -1, so that one's fine. And we could certainly rule this one out because this one's at 0, 2. All right, so that leaves C to be the correct answer, but let's say that we were given some different options and it wasn't quite so easy to tell just from the parabola. Let's look at the other curve here. So the other curve, we have x squared plus y squared is less than 9. So this is a circle, and the center of this circle is located at 0, 0. The radius here is 3. And because this is a strictly less than, we would use a dashed line for the circle. So if we go back down to this graph in C, that's exactly what we're looking at. We have a circle, radius 3, and it has a dashed line. So that checks out. The parabola is opening upwards. We're using a solid line for it. That checks out. The vertex is in the right place, of course. The only thing that we might need to test again is where we're shading. Because like this is one region that could be a potential solution. This is another region that could be a potential solution. This is another region that could be a potential solution. So how would we know it's this region as opposed to all these others? Well, one thing you could do is you could pick a test value in every single one of these regions and see which one works for both systems, both of the equations in the system. Or what we could do is just kind of treat them separately. So like for instance, if I picked 0, 0 to test with the parabola to see which way the parabola needs to be shaded. Well, then I'll take 0, 0 back to the parabola's equation, and that would give me 0 is greater than or equal to 0 squared minus 1, or 0 is greater than -1, which is a true statement. So for the parabola, we would shade the side of the parabola, and I'm using the word side loosely here, but the side of the parabola that contains the origin. Then with the circle, if I need to test if it's the inside of the circle or the outside of the circle that needs shaded. So I need to make sure I pick a point that's clearly one side or the other. So again, the origin's easy. So that would be 0 squared plus 0 squared, which is 0, is less than 9. So that's also a true statement. So then the inside of the circle is shaded. And then it's the region where all of these shaded regions overlap. That is the solution region. So that's why we have that region there. So everything checks out. C is our answer.